Uh, you know what? Because it's already time. So can you meet with me during my office hour? Yeah. Oh, due to 9. Oh, yeah, it's due to 9. Or you can meet with me after. Yeah. Uh, Good afternoon, everyone, and want to welcome you back from Thanksgiving break. Can you hear me, right? Okay, so I hope you enjoying your Thanksgiving break, right? Okay. Um, we want to continue with our lectures, and of course, the final exam. We're actually counting down to the final, and of course, the final has a huge weight. Uh, I told you the other time. Of course, this week I'm going to release what I'm going to call the final exam guide. Okay, so please pay attention to the topics that we actually, I think from chapter 8, 9, and 10. Okay, chapter 8, 9, and 10 will form the short answer question in the final, 60%. Chapter 8, 9, and 10, and 40% will be the rest of the chapter, and that will be multiple choice. The rest of the chapter will be multiple choice, while the short answer is going to be chapter 8, 9, and 10, the one we're doing now, okay? 8, 9, 10, this 10. Okay, so I want to welcome you to, and before I get started, I've been recording, and I've been sharing that on Canvas. It's also on YouTube. Okay, in case you want to watch the recording, I want to start chapter 10, which is the last chapter in the semester. Today, the focus is going to be on one sample hypothesis testing for me. Like I said, I need you to pay attention, listen carefully. In case you have questions, of course, you can direct that to me. In the outline today, I'm going to introduce you to hypothesis testing. And of course, like I said, we're going to focus on one sample test, uh, based on mean. We're going to consider a situation where we got known population variance, and we're also going to consider a situation where we got unknown population variance. Now I'm going to start. What do I mean by statistical hypothesis? Let me tell you this. Hypothesis is an intelligent guess, okay, about the value of a parameter, an intelligent, okay, guess about the value, of parameter, okay? That is what we call hypothesis, okay? We can say it's an assertion about the value or a guess about the value of a parameter. Of course, I told you the other time, a parameter is whatever we want to figure out, something we don't know. That's what we call a parameter, okay? I remember the other time I gave you the definition of parameter as a population characteristic value. Okay, parameter. Okay, population. Okay, characteristic value. Okay, that we seek to determine, that we seek to determine. You know, the parameter could actually be average annual household income in a particular country. It could be proportion of the citizens that approve the job the president is doing. It could be mean, it could be variance, it could be proportion, rate, pass, all like that. And you know what? That's what we call parameter. But our mind can never be empty. We normally have a certain value in mind about what the value of parameter is going to be. Okay, so when you have a value in mind, that I actually call an intelligent guess. You know, you just guess it, maybe through your observation, you guess the value to be like that, then that is going to be called hypothesis. Okay, so by hypothesis, you are trying to like having an assertion about what the value of parameter is going to be. Can I say this? 60% of Americans approve the job the president is doing or not? Okay, or can I say below 50% approve the job the president is doing or not, and stuff like that? That's an hypothesis. Now, let me tell you this. You know, the formal procedure for hypothesis is actually, you know, similar to what we do in science. Okay, let me tell you this. When we have an hypothesis, when you have an intelligent guess, the next thing we're going to do is to put that to test. Okay, because of that, we're actually going to have hypothesis testing. Okay, the hypothesis testing now means testing the validity of a claim. This is a claim, like somebody having a guess. Okay, how valid it is, okay, is what we're going to be called hypothesis testing. So here now is testing the validity, okay, of a claim. So that is what we mean by hypothesis testing. And let me now tell you, if I want to look at the procedure in hypothesis testing, okay, it's more or less similar to what we actually do in scientific community. As scientists, we observe nature, okay? You know, scientists observes nature, okay? It's going to observe nature, okay? And it will formulate theory, okay? I want to do this. He or she, okay, formulate, okay, theory. You know, he or she formulate theory, okay, and test his theory, his or her theory, against observations. Now, let me tell you this. When you observe nature, right, based on what you see, something is going to come to your mind as an intelligent guess. Then, based on what comes to your mind, you formulate theory. When you formulate theory, you are hypothesizing. You're actually assuming that the values of a parameter is something. Then what are you going to do? You need to take a sample, okay, of data and test whether there is an agreement between your observation and the theory. Okay? You want to test. Is there an agreement between observation and theory? Okay? If there's an agreement between them, then you will fail to reject your hypothesis. Okay? But if there's a disagreement between observation and your theory, okay, then you're actually going to reject what you have in mind. So what you have in mind, okay, is an intelligent guess. Like our mind can never be empty. Let me tell you this. Let's say this guy is accused in a court of law, okay? Now, this guy is going to be presumed innocent unless court prove otherwise, okay? What is court going to, which means court has an hypothetical statement in mind. They have something in mind that, oh, okay, maybe the prosecutor actually think that this guy is guilty, right? Now, the court is not going to take a judgment immediately. They're actually going to take observation, like evidence, cross-examination, and so on like that. And at the end of the day, they're actually going to see, is there an agreement between what they observe and the theory? Does that make sense? It's either there's an agreement or there is disagreement. And that is the reason why we're actually going to have two forms of hypothesis. We're going to have the non-hypothesis. We're going to have the alternative hypothesis. The non-hypothesis is going to tell you, it's actually it's a statement about the population we want to disprove. The non-hypothesis is what you have in mind, okay? That the value of a parameter should be, okay? And you collect your data. You actually want to see whether you should go against that or you should fail to go against that. Why there exists another hypothesis called alternative, okay? What we hope to find evidence for. I know the prosecutor in the court of law really want to find evidence that will nail the suspect. Does that make sense? They want to find evidence that will nail the suspect, because I want to believe the HO, the non-hypothesis, is that the suspect is innocent. Alternative is that he's guilty. I'm going to show you something now. And before we go into this, because we're going to be using statistical model to conduct a test, then we're actually going to rely on assumptions. I told you the other time, model is not the same as reality. We want to use model to capture reality. We want to know the mind of the nature, but our model cannot give us exact reality. There's always going to be an error. Okay? And therefore, if there's an error, there's going to be an assumptions. Because assumptions will revolve around the error. Now, the assumptions here, I'm going to tell you, okay, by the time we get to the test. Now, take a look at this guy. I need you to pay attention to the first one. This is if we want to start testing hypothesis, we actually need to specify what is our non and the alternative. Symbolically, okay, we normally denote non-hypothesis as HO, no, HO, okay? While the alternative, we can actually say H1 or HA. Does that make sense? The non and the alternative hypothesis, they are mutually exclusive. Okay, one is going to negate the other. Does that make sense? Okay, and if you take a look at that, maybe somebody claim that in a particular company, okay, the numbers of defective, maybe the percentage of defective is 10%. Or maybe somebody says it's not more than 10%. Not more than. Not more than 10% is going to be this, right? It's going to be this. Not more than. But when we want to write a symbol under the null hypothesis, we normally write equality. So this guy can be read as this. Does that make sense? So whether this guy or this guy, in the null hypothesis, we're normally going to consider equality. I need you to pay attention now. Whether less or equal to, or greater or equal to, we're actually going to what? Consider equality sign under the null hypothesis. And let me tell you, if I'm talking about less or equal to, what am I going to have under the alternative? It's going to be opposite of this. The opposite of this is going to be greater than. What is the opposite of this? It's going to be less than. So, which means under the alternative, Under the alternative, we're actually going to have greater than, less than, or we're going to have not equal to. So three possible signs under the alternative is that strictly less than, greater than, or not equal to. But under the no, it's always going to be equality sign. Even though we know less or equal to, we also be equality sign, greater or equal to, we also be equality sign. Now, which means the HO here is actually less or equal to. There, that we wrote equal to. Maybe the manager believe in a particular, company, the percentage of defective is not more than 10%. And the alternative is going to be what? More than 10%. Now, take a look at this guy here. In the court of law, the non-hypothesis, defendant is innocent. Okay? Alternative, defendant is guilty. Okay? And of course, you're going to say at the end of the day, a court, we have to take a decision, okay, on any of that. But they can't just go ahead.
Are H0 and H1 complements?
Exactly. They complement each other.
Okay.
That's a good question. They complement each other. You know, they go against. When they go against, then the two of them complement each other. Okay, now we want to go into hypothesis testing now. And what is the role of probability? Let me tell you this. We are using a model. And in our model, we believe that our model cannot give us exact reality, okay? Because of the fact that we live in a stochastic or probabilistic world, and because of that, there is possibility we could be taking wrong decision. Does that make sense? And that is the reason, because of our model, it's probabilistic. And that is, and outside decision procedure must include awareness of probability of a wrong conclusion. That's the reason why somebody is not satisfied with a decision in a particular court, the person can appeal, because there is possibility that the court take a wrong decision because the court, none of them actually present at the scene of the incident. They're only going to take a decision based on information, based on what? Based on the evidence before the court. The same thing in research. There's possibility we could mislead the world. But you know what? We acknowledge that fact, and of course, all what we want to do is to make sure that we minimize that event. Now, I want to go into, if I want to test hypothesis now, okay, I actually need to go by way of procedure. You know, what are the statistical procedure, you know, that I'm actually going to follow. Number one, we care about assumptions. Okay? A model is as good as assumption put into a model. What makes a model to be great is when all assumptions hold. For instance, if I want to talk about the court of law now, and in a court of law where somebody is actually being accused of wrongdoing, then the court shouldn't be biased in the trial. They have to make sure they use principle of randomization in selecting people that will come, the witnesses that will come to court. Does that make sense? Otherwise, and that was why random sample, you got to make sure, you know, I told you the other time, since we're not going to study everybody, okay, I want to believe the court will not call everybody at the scene of incident before they take a conclusion. But the sample they're going to choose, they got to make sure it's random. Random means anyone has equal chance of being selected. Okay, that is number one. Number two assumption. Oh my God, we come in again. Normality. Normality. In this class, we talk about normal distribution. Okay, discovered by what is it called? De Moivre 1733. You know, the population we're choosing from we have to ensure that we have a normal distribution. That population follow normal distribution. How am I going to know? You're actually going to be told in the question. And if the population does not follow normal distribution, okay, but by central limit theorem, if we take a reasonable large sample size, and how large is the large? At least 30, okay? Even if the population is not normal, okay, the distribution of the statistic will be normal, okay? We requires normality. So population distribution is approximately normal or sample size is large. The sample size is large. How large is it large? At least 30. Does that make sense? Okay, now if all those assumptions hold right now, we want to conduct a test. What kind of test do we want to test? What kind of test is this? Maybe for instance, we want to conduct a test on average. Somebody give us an average. Maybe for instance, I want to know what is the average minimum wage in the United States. And somebody says, okay, the average minimum wage is $10. That is an hypothetical statement. It is not something that I'm going to say, yes, it is $10. We don't do that in science. In science, we actually want to investigate that. Okay, that's a statement. That is hypothesized value. And let me tell you, that's a claim. And let me tell you this. Investigation follows a claim. Whenever a claim is made, the next is investigation. Okay, so that's what we want to do now. We want to focus on a single population, and we want to test hypothesis about mean. You remember in chapter 9, we've constructed confidence interval about it, right? But right now, we're no longer interested in confidence interval, but we want to test hypothesis about it. Now, take a look at this. We test an hypothesis about mean. Of course, this is the specification. We could be testing hypothesis about any of these three. I needed to take a look at the non-hypothesis. In any of that is a quality sign. I told you the non-hypothesis will always have a quality sign. Don't make a mistake in exam. In the non-hypothesis, it has to be quality sign. Whether it is greater or equal, it's going to be quality sign. Whether it is less or equal, it's going to be quality sign. But why the alternative? Is going to be strictly less than or greater than or not equal to. So where you have less than, this is lower tail tells. Lower tail tells. This is an upper tail tells. This is a two tail tells. Two tail tells. You know, when you take a look at the first two, this guy and this guy, we call them directional tells because you know the direction. But this guy is non-directional tell. You don't know the direction. It could proceed in two ways. That was why we call it two tells. Does that make sense? These are three possible hypotheses, formulation. But let me tell you this. When you are given a question, you are going to be the one that will figure it out. You know, it's either for a particular problem, maybe what you want to test may be this, or this, or this. We don't test for all of them at a time. You're actually going to choose appropriate one based on the question. Does that make sense? And which means in every hypothesis testing, we normally start with a specification of the known and the alternative. Of course, I want to believe in the court of law. If they want to start a case, they're going to say court. They're going to say something and say, okay, are you guilty or not? They're going to start with that. That's where they're going to start from, guilty or not. But what is the assumption in the court? The assumption in the court is that that very court must have a territorial jurisdiction to answer the case. Before you can try somebody in a court, it means that person has broken the law, okay, under the jurisdiction of that court. Before I can conduct an hypothesis testing right now, I need to be able to first investigate whether the distribution of the population is normal or not. If it is not normal, I should be ready to take a large sample size. And how large is a large? It has to be at least 30. Any question before I move on? Okay. Now, I need you to pay attention. When we are testing hypothesis, then we need a criteria to take a decision. And we normally make use of, it's either we make use of the rejection region or we make use of a p-value. And what do we mean by p-value? The p-value is the probability that we're actually going to observe an extreme value when the non-hypothesis is true. You know what is the non-hypothesis? The non-hypothesis is hypothesis of no effect, of equality. The non-hypothesis is going to say there is no difference between the real world and the hypothesized value. They are more the same. That's what the non-hypothesis is saying. Alternative is the one that detects a difference. Does that make sense? And that's exactly what we're trying to say now. Now, we compute our p-value. Now, I need you to take let's say, for example, we're working with the z-test. Okay, the way we compute the p-value, okay, what determines the computation of p-value is the nature of the alternative. I need you to listen now. I need you to listen. I want to compute my p-value, but I need my p-value to take a decision. What will determine the p-value? I need you to pay attention to hypothesis number 1. Okay, what do you say? The p-value is z less than. Why is it z less than? Oh my God, because the alternative here is less than. I'm going to say that again. In the computation of p-value, okay, you need to put into consideration the nature of the alternative. Whatever the sign, whether less than or greater than or not equal to, whatever the sign that you see in the alternative will actually need to be put into consideration when you want to compute the p-value. Now, for hypothesis 1 now, I want to compute the p-value. It's going to be z less than. For hypothesis 2, what is the alternative in the hypothesis 2 is greater than? My p-value will actually going to be z greater than. What about hypothesis 3 that is not equal to? Not equal to, then if I were to compute the p-value, I'm going to multiply by 2. What am I multiplying? The probability of the greater than the absolute value of that. Any question? Please don't make a mistake. Final exam has a huge weight. Okay? And like I said, chapter 8, 9, and 10 is 60%. That's a huge one. And that's why I need you to pay attention now. Now, what you see here is a graphical representation. Less than, it's going to go to the left side, right? Less than. Okay, greater than, to the right side. Then this guy, two-sided, it's going to be one less than this, greater than that. So what you see here is a graphical representation of that. Now, that is one way to take. So if I want to take a decision here, when I calculate my p-value, I'm just going to compare my p-value with the level of significance. In every test, there's always going to be level of significance given. What do I mean by level of significance? That's what we call alpha. That is a level of statistical error. You know, when we're dealing with the confidence interval, when I say 95% confidence, then what is the level of significance? That would be 5%. If I have 95 confidence, so the level of significance is the level of statistical error. Okay? The level of statistical error. What do I mean? When I say level of significance is 5%, alpha, we normally call it alpha. What do I mean by saying the level of significance is 5%? It means in my research, I'm actually going to mislead the world only 5 times out of 100. That's okay. Because you know why? Because our model is not the same as reality. Does that make sense? That's what I mean. Okay? Now, in taking decision, we're always going to compare the p-value with the level of significance. The level of significance will be given, okay? Then I'm going to tell you how to take a decision. Another way to take a decision is to use a rejection region, okay? Now, take a look at this. When the alternative is greater than, I will check this value in the table. You know, we checked this value the other time when we're dealing with confidence interval, right? When the z, there's going to be a z calculated. Okay, this is the formula of the z, which I'm still going to show you. The z is going to be your sample mean minus hypothesized value. Okay, there's going to be an hypothesized value. Where do you get your sample mean? You're going to get your sample mean from the observation, right? What are you doing here? You're looking at the distance. And I told you the other time, you really want to investigate, is there an agreement between your observation and reality? Okay? There's going to be the standard error. Okay, I'm going to show you. Now, when this value is greater than the one I'm going to check in the table, okay, we're going to reject HO. When I'm dealing with the lower tail test, where the alternative is less than, I'm only going to reject the non-hypothesis when this happens. And for the two-tail test, I'm going to reject the non. So there are 2 ways of taking decision. Okay, whether one way is to make use of a p-value, another way is to make use of this. I'm going to walk you through this very, very easy. All what I need from you is to pay attention now. Okay, is everyone paying attention now? Everyone paying attention, right? Good job, good job. Okay, I can see you now. Okay. Now pay attention, okay? Final is very, very, has a huge weight. And I want the minimum in this class to be 99. That's possible. Pay attention now. Okay, now, you know, this is if I want to test lowercase, right? If I want to test lowercase, I will only reject the non-hypothesis when z is less than negative z alpha. If I'm testing two-tail, I'm going to reject if that happens. Now, I want to walk you through an example now. Please pay attention. Let us go through this together. A vice president in charge of sales for a large corporation claims that salespersons are averaging no more than 15 sales. How can I interpret no more than 15? Can somebody tell me? No more than 15.
That would be less than 16, right?
Is it just less than? No more than 15. No more than. Go ahead. Less than or equal. Send me a message for extra credit. Oh, by the way, if you have not used your extra credit before, you can be piling up that until you write the final. When you see the result of the final, you go, okay, Professor, can you add my extra credit to my final? Or whatever, to assignment or whatever. When you say no more than, please pay attention. No more than means less or equal. Okay? No more than actually means less or equal. Now, please, if you want to formulate your hypothesis based on the question, they say no more than means less or equal. Which means in the non-hypothesis now, okay, it's going to be mu equal to something, equal to 15. Now, what will be in the alternative is going to be opposite of this guy. What is the opposite of less or equal? It's going to be greater than. So this guy now is going to be, and that was how you actually have this formulation. If you want to formulate an hypothesis based on mean, this is wrong. We don't formulate hypotheses based on sample mean. We formulate hypotheses based on parameters. Does that make sense? So parameter for the mean is mu. Does that make sense? We don't formulate based on sample mean. Now, it would like to increase the figure. It would like to increase the figure. It want that. Does that make sense? But this is a specification now. Okay, as a check on his claim, okay, 36 expressions are selected at random. One of the assumptions kept. Which assumption? Random. Does that make sense? Because when you specify a claim, okay, investigation will follow a claim. Does that make sense? He has made a claim, and we need to investigate that. We don't want authoritarianism. You can't tell me something and say, okay, that is it. No, I have actually going to check. Okay, are selected at random, and the number of contacts made by each is recorded for a single randomly selected week. The mean and variance of the 36 measurements were 17 and 9 respectively. Does the evidence contradict the vice president claim? Use a test with the level alpha equal to 0.05. I told you the other time, whenever they ask a question on hypothesis testing, they're actually going to give you the level of significance. The level of significance there is alpha, 0.05. Now we want to test now. Now, the very first thing you're going to do, specify your known and your alternative hypothesis. If you don't specify them correctly, you're actually going to get it wrong. Okay, now I need you to pay attention to this because there's a kind of, disagreement between, there's something that we call a z-test or a t-test. Which one am I going to use? Is it going to be a z-test or is it going to be a t-test? I need you to listen now. When do we use a z-test? When do we use a t-test? Because I've used a z here. Z-test is what I'm using now. But when am I going to use a t? Now, the condition to use a z-test is, number one, when the population variance is known, okay? Or when the population variance is unknown, the sample size has to be large. I'm going to say that again. The condition to use z-test, okay, is either you are giving population variance, or if there is no population variance, the sample size has to be large. And how large is the large? It has to be at least story. Now, if you take a look at this, they didn't tell us the distribution. In this question, there's nothing like normal, but there's something I can see. Oh my God, the sample size 36. When the sample size is 36, that actually means the sample size is large. When the sample size is large, okay, the test statistic will follow normal distribution as given by central limit theory. Now, because of that, I'm actually going to use, even though here, they didn't give us population variance. How do I know? They didn't give us population variance. Take a look at this. They said the mean and variance of 36 measurements, which means they give you sample mean and sample variance. Take a look at that statement. There's a difference between sample variance and population variance. Even though in this question now, the population variance is unknown, but because the sample size is large, how large is the large? It's at least story. Here is 36. Then I'm going to use a z. Then from that, I can actually, I can say, okay, because of that, for a large sample theorem, I can use the fact that, okay, my sample mean approximately follow normal distribution with the mean of this and the variance of this. Now, if I want to use my test statistic now, it's going to be Z equal Y bar. The Y bar is going to be sample mean minus, do you see mu naught? Mu naught is an hypothesized value, the intelligent guess. Divided, what is this? This is the standard error. We're going to be square root of sigma square over n. Right now, what is 15 is mu naught. That is the value under hypothesis. Mu naught, 15. Then here I'm going to put the sample mean. They've given you that, what is the sample mean? The mean and the variance of 36, 17. Sample mean is 17. Sample variance is 9. Then I can actually, now if I do that, okay, take a look at this. What am I doing? I'm already plugging that in. Sample mean is 17. The hypothesized value is 15. The variance, okay, even though initially it was sigma squared, the sample variance can replace population, the sample variance can serve as an estimate for population variance when the sample size is large. Okay, that was why, 9. Then the sample size is 36. What do I get at the end of the day? My test statistic actually give 4. Okay, when I compute this, that give me 4. Now, if that give me 4, the next thing I'm actually going to do is to go into the table. If I want to use rejection region, R means rejection region. Oh my God. How do I know the rejection region is going to be Z greater than? Because of the fact that my alternative is greater than. Whether you want to compute your p-value or you want to decide on the rejection region, the sign in the alternative is very, very important. Now, you know what I'm going to do now? In the rejection region, you know what I'm going to do? Z alpha. I got Z alpha, right? I want to check that from a normal table. What did they give me as my alpha? 0.05, right? So it's going to be Z 0.05. If I check that from a normal table, okay, Z 0.05, that will give me 1.645. Okay, now, rejection region claim that when your Z is greater than the one you check in the table, you're actually going to reject H0. Your Z, your calculated Z is 4. The one you check from the table is 1.645. The one you calculate is greater than the one you check in the table. And if you look at the rejection region, that means this guy 4 in the rejection region. Do you know the meaning of this sign? This sign means lies in the rejection region because the calculated value of Z is greater than the critical value, the one I checked from the table, and I'm going to reject H0. Rejecting H0 now, right? Rejecting this, it means I'm here. Okay? Now, what are we going to say? Conclusion? We're actually rejecting H0. Okay? Conclusion? At alpha equal to that level of significance, the evidence is sufficient to indicate that the VP's claim is incorrect. Don't forget, the VP claim was that it is no more than 15. But right now, that claim has been rejected based on the evidence. Okay, it's incorrect, and that the average number of sales, okay, contract per week exceed 15. I'm done. Any question? I'm done. I'm done. This is how to take a decision now. Based on 36 observations, you can see that that claim is not correct. But here, I've not used p-value. I use rejection region to take a decision. Now, I'm going to quickly walk you through an example because of my time. Take a look at this. A random sample of 100 recorded deaths in the United States during the past year show an average lifespan of 71.8. Okay? Assuming a population standard deviation of 8.9 years population standard deviation that is given out, right? Whether, I said population variance or population standard deviation. Now, does this seem to indicate that the mean lifespan today is greater than 70? Mean lifespan, where can I have a greater than sign? Alternative. Okay? That is why, take a look at this guy now. Alternative is going to be greater. The null hypothesis is only going to be equality. I told you. Okay? Now the alpha is that. Then I'm actually going to use Z. Why am I using Z? Because right here we're told we're giving population standard deviation. When I compute that, I got 2.02. Then if I check from the, from the table again, at 0.05, I got 1.645. 2.02 is greater than that. Because of that, I'm actually going to say, because the value here is greater than 1.645 that you check in the table, that it means it falls in the rejection region. We're actually going to reject H0. But let's say I want to calculate p-value. What am I going to do to calculate p-value? Let's say I want to take a decision using p-value. Okay? How do I get my p-value? Please pay attention. I want to find the probability of Z greater than what I got. What do we normally do when you are talking about greater than sign? Whatever value you check in the normal table, you subtract from 1 to get this. Now, this is a p-value now. Now, let me tell you, how do we use p-value to take a decision? Okay? When p-value, please take note. When p-value is less than alpha, reject HO. Okay? When p-value is greater or equal to that, fail to reject HO. If you want to make use of a p-value, in taking a decision, we normally reject when p-value is less. Now, let's see. This is p-value, right? Compared to what was the alpha given? 0.05, right? This is less than that. What are we going to do? We reject. You can see we've taken the same decision, whether using the p-value or using the rejection region. Any question? We don't. And if you want to conduct an hypothesis, you see the step? You see the step? Hypothesis formulation, level of significance, the critical region, your computation, your decision, and your conclusion. Take a look at that. Okay. Now, I got 5 more minutes. Now, this is an example of a two-tail. Okay, how do I know it's a two-tail? If you take a look at what I had, test the hypothesis. Of course, they're giving you that directly. Not equal. You're still going to do the same thing all the way. But if you want to find your p-value, we need the absolute value. Okay? And absolute value of that greater than that is going to be 2. If I want to change this greater than sign to less than sign, this guy is going to change to negative. Look at what happened. Changing the greater than sign to less than sign, then you're going to change the sign here. That's a negative, right? Then I'm going to check this from a normal table. I will multiply by 2. Why am I multiplying by 2? Because I'm dealing with a two-tail test. This is my p-value. Compare p-value with the level of significance given. Here you're given is 0.01. If a p-value is less, you reject HO. Okay, here, that allows us to reject HO. Okay, now all we've been doing, we've been talking about Z when do we use t-test. I'm going to give you an example now. For t-test, I'm not going to be talking about Z anymore, but I'm going to be talking about T. T instead of Z. You see why chapter 8 is very important? Okay, now, the same way I want to test hypothesis, but this time around, in my p-value, it's going to be the probability of T, not probability of Z. And we're going to be needing degree of freedom. Okay? And that is the way to conclude. When p-value is less than alpha, always reject. When p-value. Now, let's go to an example now. This is the last slide. Why is this a t? Right? We're actually going to see why is a t. Let's look at the sample size. If a random sample of 12, the sample size is small. Can you see that? The sample size is very small. And not only that, the population standard deviation is not given. But let me tell you, it's still going to be the same approach, except that we are changing z to t. And we're going to be checking from t table. After getting this now, I got t to be that. Why do I want to, if I want to find a p-value, why do I have a less than? Because the alternative is less than. Then I'm going to check this from the table using the degree of freedom. What is the degree of freedom of 12? That would be 11, right? Oh, okay, we got 12. 12 minus 1. You know, we want to check a t table. At the end of the day, we get a p-value. The same decision that we normally take, we compare p-value with the level of significance. Where p-value is less than the level of significance, we always reject. I've seen a lot of final exam questions today. A lot. Yeah. If I were you, master all of this. Okay. Oh my God, that's going to be the end of this class. Is there any question to ask? Any question? Any question? Okay, make sure you stay safe and have a lovely day. Bye for now, everyone.
Last,